going on, guys? Let's look at this problem right here. Here this question is asking, calculate the collector current of Q1 in figure 5.18a. Assume beta is equal to 100 and Is is equal to 10 to the power minus 17 ampere. Now first let's go ahead and find out the VThevenin. Yeah, here you can see the Thevenin equivalent circuit of this one. Okay, here we have the Thevenin equivalent circuit. Now first to find out the VThevenin, we use the voltage division. R2 divided by R1 plus R2 multiplied by VCC, and if you plug all these values you will get 800 millivoltage. Now our initial guess for VBE is going to be 750 millivoltage, because when it passed through the Thevenin equivalent resistance there's going to be a voltage drop, so it must be definitely less than VThevenin. VThevenin is 800 millivoltage, so we guess VBE to be 750 millivoltage. And if you calculate IB using that, VThevenin minus VBE divided by RThevenin, and that will give us IB, and that's equal to 0.919 microampere. Now from this one we can calculate IC. IC is equal to beta times IB. Beta is given 100 times 0.919 microampere, and that gives us 91.9 microampere. So VBE is going to be equivalent to VT times ln of IC over IS, and that gives us 776 millivoltage. Okay, now this is first, then it follows, IB follows to be, when we do the accurate values, IB follows up to be 0.441 microampere, and IC will follow with 44.1 microampere, and then continuing iteration, we get VBE to be 757 millivoltage, and IB becomes 0.79, IC becomes 79, and after many iterations VBE becomes 766 millivoltage and IC becomes 63 microampere. And that's it. That's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.